Welcome to the MS SQL Tips webinar, Azure SQL Database Performance, sponsored by IDERA. I'm Greg Robidoux, co-founder at MS SQL Tips and today's webinar host. Joining me today are Joey DeAntoni, who's a senior architect and SQL Server MVP, as well as a frequent speaker covering many different SQL Server topics, and Justin Wilkes, who's a sales engineer at IDERA. Before we get started, if you have questions, you can submit them any time during the webinar by entering your questions in the question area in your presentation controls. We'll try to answer as many questions as possible during today's event. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, watch on-demand videos, and register for our live upcoming webinars. Today's webinar will be recorded and archived for future playback, and you'll receive a follow-up email with links. So at this time, I'll turn things over to Joey, and he can get started.
Hi, thanks, Greg, and welcome everyone. I know performance is always like a hot topic, so it's fun to talk about. Today specifically, we're going to be talking a little bit about Azure SQL Database performance, and I just wanted to kind of mention terminology here a little bit because Microsoft uses a lot of marketing terms, and sometimes they change names, and this is really confusing. So specifically today, I'm going to talk about the Azure SQL Database service. I'm also going to make some mentions a little bit of Azure SQL Managed Instance. Some of the tools that we have available that we're going to discuss today are similar in both product offerings, but they differ a little bit slightly. And specifically when we talk about Azure SQL Analytics, there's a little bit of a difference in how they're implemented in Managed Instance versus SQL Database. I'm not really going to talk about SQL Server per se, but a lot of what we're talking about is going to apply to SQL Server as well. So like Query Store, Azure SQL Analytics, if you happen to be running SQL on an Azure VM, you can use, with some additional infrastructure in place, connect to the Azure SQL Analytics service. So just keep that in mind, and remember, Microsoft's only changed the name of Azure SQL Database like twice or three times. The original name, if you're old like me, was SQL Azure, and it had like a 1 in 5 gig size limit, and that was back in the 2010 timeframe. We've come a long way from there. It's a fully featured, great database service, and we'll talk about all the performance tuning options you have within it. Like Greg mentioned, I've been working with SQL Server for a long time. I'm principal consultant at Denny Cherry & Associates Consulting. You can find us at dcac.com. I talk a lot on database administration, career management. I've got a lot of certifications. I blog at joeydeantoni.com. You can find me on Twitter at jdanton, and I'm also a Microsoft Data Platform MVP and a VMware vExpert. So first, we're going to talk about what is SQL, or what is Azure SQL Database. I'm confusing myself on the Microsoft terminology. We'll talk about the various components and the various different services that are available and how SQL Database is implemented. We'll talk about the tools you can use to monitor it, how you can look at various solutions both from within the Azure Portal and within your Azure databases, and what external services you can use to capture data. One of the kind of cool things that Microsoft has is some ability to do enhancements around identifying queries, and a lot of this builds on top of the Query Store functionality. We'll talk about the analysis capabilities that are provided within SQL Analytics. We'll also talk about when you have readable secondaries and how you view them. And we'll also talk about automatic tuning and what your options are there. This was kind of a feature that was added in SQL Server 2017 too, but there's some other enhancements that are available in Azure SQL Database. And sorry about the spelling error on identify. So what is Azure SQL Database? It's a fully managed cloud database. And what does that mean compared to, say, either you running SQL Server in a physical server in your data center, or you running SQL Server in an Azure VM? Well, the first two things you're not going to care about are what operating system you're running on, and what what patch level of SQL Server you're on. Patching is going to be handled automatically for you, as is installation. So in order to deploy an Azure SQL database, you can click a few buttons in the Azure Portal. You can make an API call using PowerShell or the Azure CLI, or even just a straight up REST command, and then you have a database. So you didn't install SQL Server. You do have all your database level configuration options available to you. You also don't have to worry about patching. The cool thing about the way they patch, and I did an article last year for Redmond magazine where I interviewed one of the engineers on this. They actually hot patch SQL Server while it's running. So in Azure, they can apply patches to your SQL Server instance without taking it down. Beyond that, you also don't have to worry about backups or high availability. Azure SQL Database has no backup command. It doesn't have a restore command either. The backups are all handled by the platform. And if you need to do a restore, you don't issue a restore database statement. You go through the platform tools, which would be, once again, you'll hear me repeat this a few times, the Azure Portal, PowerShell, the CLI, or the API in order to restore your database that was backed up for you. So those are kind of the DBA tasks that are outsourced to Microsoft here. A lot of still what you do is your own, is like around performance tuning, isn't any different from what you do on-prem. It runs on the Azure Compute platform. So Microsoft has, I think, over 50 regions around the world now where you can run Azure. So you can put your database with readable secondaries, and you can have one that's in a data center in California that can have a secondary in Australia, that also has a secondary in India, and maybe another one in the Netherlands. And I think since you can do 4, you could go back to the East Coast, so you could go almost all the way around the world. The benefits of being on Azure is you have global scale. When we were chatting before the call, I mentioned that if you need to deploy a petabyte of storage, you can quickly deploy a petabyte of storage. You don't have to wait on anybody from your SAN team. You should note that Azure SQL Database in its hyperscale format does only claim to support up to 100 terabytes of data. But if you have more than 100 terabytes in a single database, we probably need to have a discussion anyway. But anyway, so you get the advantages of that platform. Part of the cool things about that platform are you get scale that's built in and kind of infinite. You don't have to really worry about running out of space or running out of compute. Microsoft handles that for you and has capacity management. The other thing that's cool about that is all services in Azure are kind of built to be highly available. And what does that mean in the scenario? Like if you wanted a highly available SQL Server, we know you would either build a failover cluster instance or use availability groups. Depending on which flavor of, or service level, I should say, of Azure SQL Database or managed instance, this architecture is pretty much the same between the two of them, you're using. You have different types of high availability, but you're highly available. So the way kind of RAID works in Azure underlying storage is that there are always 3 copies of your data, and the storage fabric doesn't acknowledge a write to be complete until that write has successfully reached all 3 copies. So if you're on the general purpose version of Azure SQL Database, you have 1 compute node, and then you have that 3 copies of your storage. If there's a storage problem, they simply add another replica, synchronize to it, and that all happens transparently to you. So like a storage outage won't directly cause downtime. If you have some kind of compute outage, which are pretty rare, the SLA for a standalone Azure SQL database is 99.95%, which I think works out to about an hour a year. In the event that you have a compute failure there, what happens is that just a new instance of your compute is spun up and connects to that same storage. So you have that highly available model. If you're using business critical, it works a little bit differently. It's more like an availability group where you have 3 instances of compute, and the storage is actually local. So that's where they get the 3 copies of your data. The storage is local flash storage that's on the blade that those VMs are running on. And that does use the same underlying technology as an availability group. So most database management is handled without DBA involvement. So we mentioned you're not installing SQL Server, you're not patching it, you don't have to worry about taking those backups and ensuring those backups are in place. I will caveat, there's a little bit of a difference with managed instance here. With managed instance, you can take your own copy only backups, but you can't back up your you can't. The service fabric is responsible for backing up all of your databases on a normal basis. So it's out of your hands. Benefit here, you get to focus on kind of fun stuff, and there's a lot of tooling that's involved. So a lot of what we've seen in SQL Server in recent years around improving plans, execution plans based on changes in performance, like the way the query store tracks that data. Those are all things that are part of what's available to us. We also get some additional tooling, and like Microsoft has built a better version of the Database Tuning Advisor, and this is kind of a cool cloud thing where they'll suggest indexes that might be needed for given queries. And what they do is they actually spin up a second instance of your database, and they build those indexes there. So they split the TDS stream that's coming from your client into your database. So they test out in the background the new indexes they've built and see if they actually make improvements. And this is all public. It's in a ACM white paper that Microsoft wrote. And that allows them to decide if those indexes are good, if they're going to benefit your workload, and if they are, it will surface those recommendations to you. So it is the Database Tuning Advisor, but it's a lot smarter. The big thing you need to know, and this kind of ties directly into cost now, is that performance monitoring and tuning is still needed. So you need to understand what's consuming those resources. In most cases nowadays, we're deploying SQL databases with vCores. And there's a specific ratio of memory to the number of cores that you have. So you want to understand what that hardware profile looks like, but you still need to be able to tune those queries because if you have more vCores, your cost is going to go up exponentially. So this is a case where as a DBA, you can show your worth immediately by providing those kinds of insights. So Azure offers several included components to performance tune your workload and database within the portal. And one thing I kind of want you to remember is that anything you see in the portal is going to be the same as what you can access via code or PowerShell or anything like that. So here I'm going to log into another portal window real quick because I want to switch identities. By the way, this button's a lie. It doesn't keep you signed in. So here we're going in, and this is my MVP sub. I have a sub that's got some actual performance data that we'll see in a minute. While we wait for this to load, so here we'll go to SQL servers, and remember your SQL server is just a logical construction. All your performance information is going to be aggregated at the database level because that's where we have data. And I haven't run anything through this database, so you can see my compute utilization is basically 0, and I can click on it for 24 days or 7 days. This metric collection here, and right now it's on DTU percentage, which was the older way you could buy Azure SQL Database, which is database throughput units. It's simply graphing that metric. But if we look, I can see I have a number of different collectors that I see data space used, set log IO percentage, sessions complete, process core percent, tempdb. So I have a number of different things I can collect, and this is just on by default in Azure SQL Database is capturing all of that data for you. There are some other tools that are a little bit more SQL specific, and we'll talk about those here in a minute. So Azure Metrics and monitoring, the kind of cool thing about, and that's the screen I just showed you, metrics and monitoring and alerts are all pretty common throughout all of Azure. So one of the classes I'd like to teach, and I'll be teaching at SQL Bits, and I taught it in Belgium in October, is kind of an admin to architect class that takes you beyond just SQL Server stuff and moves into to broader architectural concepts in Azure. And one of the cool things is monitoring and alerting are kind of a single platform within the portal. And of course, you can always use like your third-party tools like IDERA's tools that Justin's going to demo later. But if you want to set up some baseline alerting in the portal, you can do that. Warning, like many things in the cloud, it does come with some cost associated with it. But you can also have a dashboard for various resources that you can customize. So all that stuff integrates nicely into the whole Azure story. Query Performance Insights. This is kind of another name, and like we mentioned, Microsoft likes to name things in interesting fashions. This is another name for the query store. So this can be a little bit confusing. In the portal, you'll always see Query Performance Insights. It's the same data that's going to be in the query store. But this does give you kind of a top 5 view of the top 5 queries that are running on your SQL database. If you're not a DBA and you don't have experience writing a bunch of T-SQL code and you just want to see what those top 5 queries are on your system, this can be an easy place to look. It's accessible through the portal. It can let you easily identify that data and take action on it. And just to show you what that looks like, get back to here. Hopefully I have it turned on. So I'll drill into my database. And if I click on Query Performance Insights, I don't have any performance data because I haven't been running anything. But this will show me resource consuming queries, long-running queries, and I can customize. I can sort by log IO, data IO, and CPU. If you're on a vCore system, it'll have slightly different metrics, but that's all captured for you. And I believe that's on by default because the query store is on by default when you deploy a new Azure SQL database. By the way, one of the things you want to make sure if you are using Azure SQL Database or managed instance is that the query store is on all of your databases, because that's the only way Microsoft can collect this data. So this is kind of your interaction. As I mentioned, it's on by default on new SQL databases, but if you have one that maybe you created years ago and it might not be on, keep that in mind. Azure SQL Analytics is a little bit more advanced performance data collection solution. It's something we're using at a number of customers who are collecting a lot of data across the board. And that's kind of a deeper data collection, and Microsoft uses Azure Log Analytics to surface that information, and you'll get a dashboard, which we'll take a quick look at in a demo later. But that's going to be a little bit more detailed analysis that lets you drill through various data collections. You can write custom queries against this. Log Analytics uses its own query language called Custo Query Language, or KQL. That data is all stored in kind of a single repository, and you can have multiple databases streaming data into that repo. So there's this baseline that we kind of just looked at, and this is a database that's actually collecting some data, and I'm pretty sure this is a vCore database because we can see our CPU percentage average, our data IO, our log IO percentage, our data IO percentage, and our deadlock, and then SQL Server process consumption. So you can see kind of broadly, the server is a little bit busy. But the nice thing is you always kind of have this built-in baseline data collection there in Azure. So even if you didn't enable anything, you can go back in and check this. And in conjunction with the query store, this can give you a very rudimentary performance tuning tool. So here we see where you can add metrics. We can control the time. I think by default, metrics are stored for 45 days. I don't think they can be stored for much longer than that. There's some way you can hit 90 if I remember correctly. There is, of course, additional costs associated with that. But this is under the monitoring blade. And when we talk about the portal, we always describe these things as blades, so just FYI. So here you click on metrics. You can add additional metrics. This graph is it's fairly, sorry about that. jumped ahead a bit. So this graph is fairly correlated. We can see SQL Server process consumption is fairly well correlated to CPU, but it's a little bit ahead. You also have the option to pin this to your Azure dashboard, which is the front page you see when you log in Azure. So, if you had a couple of critical databases that you were concerned about customer information or, important customers or important databases to your business, you could pin those charts to your front page so you could see when something was acting up. I typically don't do that. I work with a ton of different customers, so like I'm logging into different Azure portals all the time. But that is one thing you can definitely do. This is something I use frequently, and like I said, in conjunction with the query store, because if I see there was a big CPU spike on Monday the 23rd at 6 a.m., I'm going to try to narrow down my search in the query store to understand what is running at that time. And which leads me to the next slide. What is the query store? And this is what drives query performance inside in Azure. This is probably my favorite new feature of SQL Server since I've been working with the product. It was introduced in SQL 2016. It's gotten better in each subsequent release of SQL Server, and we've had those improvements get passed along to Azure SQL Database. So it gives us an execution plan history and aggregated runtime statistics. And you may ask, what does that mean and why is it so important? This is kind of like a flight data recorder for SQL Server. And I'll just give you a story. One morning, I was back when I was still traveling a lot, pre-pandemic. I was in Vancouver, Canada, and I had a conference call that was taking place at like 9 in the morning on the East Coast. So I was up at 6 a.m. on a conference call. And during that conference call, another one of my clients emailed me and said, "Hey, we're having a major performance issue. Can you take a look?" And I said, yeah, as soon as I was off this call. And the issue they were having was their CPU had suddenly shot up from like, their normal baseline CPU percentage was 20%, and it had shot up to 75, 80%. And they were really concerned about running out of scale, understandably. So it was early and I had only had a little bit of coffee. So I started looking at it, the obvious things like, is there anything else running on the box that's consuming the CPU, or is it SQL Server? What's running, what's consuming CPU? And then the coffee kicked in and I suddenly remembered I had upgraded them to SQL Server 2016 and I had turned on the query store, which gave us an important thing because now I have the execution plan history. And this customer mainly ran one query over and over again. They were doing a lot of insert. It was like a logging system. And I looked and I could see the query. I could quickly sort by the query that was consuming the most CPU because that's information that's collected in the query store runtime statistics. And then I could see that there was a change in the execution plan for that query, about 4 hours before this problem started happening. What that let me do was quickly go back and force, and this is kind of the secret sauce of the query store, is if you have a plan regression like that and the old plan was working well, I was able to force the old plan. And there's a button in the query store, if you've ever used it, that says force plan in Management Studio. And when I click that force plan button, the CPU dropped from 80% just like precipitously. It just fell all the way back down to 15%. I honestly wish I had been recording it because I read an article about this story later, and I think I did a similar demo at Ignite later that year. But it would have been really cool on a live production system to have that demo recorded because we were all stressed, and then suddenly we weren't. I was like, I immediately emailed the product team that day. So this will let you show query regression, and that's how I was able to quickly identify this. There's a report that will show you regress queries. In my case, I could just see that all of a sudden in the chart, the query was taking a lot more time. It also captures top resource consumption, and it captures your resource consumption over a number of dimensions. So it will tell you, how many IOs the query did, how long it took to execute, how much temp DB, how much memory was consumed. number of executions. So you can find all these things. The only catch to the query store is it's in SQL Server. Of course, you have to use Management Studio to see these reports that are easy. If you want to get more advanced, you have to know some T-SQL. And Azure SQL Database isn't always managed by DBAs, right? Sometimes it's managed by devs who are just consuming the database as a service. So Query Performance Insight gives us a little bit more information there. And to me, it's one of the more useful things within the Azure portal. So I showed you how I got to the screen, but this one has a little more data. This takes advantage of that data that's collected within the query store and tracks runtime stats, including your query duration, how much CPU that query consumed, and allows a DBA or a developer to very quickly identify queries that are affecting overall system performance within a time range. So here we can see this time range is like 6 hours. And we can see our 5 largest queries within those 6 hours. And we can see them on these 3 pretty straightforward dimensions, CPU percentage, data IO, and log IO. One thing I will mention, you've seen log IO in a couple of charts that I've shown so far. If you're doing heavy insert workloads, and Microsoft has made some improvements of this space, but in general on SQL Azure, I find log throughput's a bottleneck for heavy insert systems. So depending on what you're doing, like I think their official recommendation to solve the problem is to implement in-memory OLTP, which is not the easiest thing in the world to do. But it is something that you should consider, or just working around or designing around, scaling out. But you will see log IO percentage a lot of times as kind of a bottleneck there. So that's something to be concerned about. But we get all of our execution counts, which is another key metric. So here we can see that, this bottom query 195, sorry about that. My mouse is really jumpy today. 1937085, or the blue query, even though it didn't consume that much CPU, it was run 9,000 times in the time frame we're looking at. So even a minor performance improvement can be helpful there. Or it's running out of control. I've seen applications where somebody screwed up in the application code and all the queries were getting executed twice. So that is something to keep in mind. And we see our top consumer there has been run 170 times and has by far the longest duration of any of those queries. So in both those cases, if you drill in, you click on that query ID, Query Performance Insight will show you the query text, and it will show you the hourly runtime information, so you can see any skew, like maybe you're getting affected or one resource is blocking another, which is another common problem that we run into. And it will show on this next slide, we'll dig into the query detail. So here we can see the query ID. You'll note this query ID. So in this case, 206.49733, that query ID links directly to the query store. So if you wanted to just quickly glance at Query Performance Insight in the portal, or maybe even have an alert that was driving off of this, you can quickly identify that. We see the details of this query. If anybody's worked with SQL Server a lot or used everybody's favorite tool, Entity Framework, which has helped pay for my mortgage, you're going to be fairly familiar with the parameters that go up to 1,000 plus. So not the query design I would recommend. I believe this is, I borrowed the slide from one of my coworkers, and I believe this is an actual client query that was constructed using Entity Framework. But here we can see that all of our executions were between 8 and 9 p.m. and we were consuming 16% of our CPU. It's probably because the optimizer was crying because it was trying to generate a plan for this query that had all these parameters. That's kind of a different problem, but this can let you quickly identify this to start focusing. like I said, if you're comfortable with query store, you're comfortable writing T-SQL, you can take this query ID and then dig into the query store, either pass it into some of the reports in Management Studio, or even write queries against the query store DMVs to start calculating this data. So Azure SQL Analytics, this is one of my favorite things that's in all of Azure. This is something that's confusing, and docs weren't super clear to me. And the first bullet says relies on log analytics, storage accounts, or event hub, and that's kind of inaccurate, and I edited my slide and missed this. My understanding based on docs, and I filed a pull request against the doc today, that in order to get the full benefits of Azure SQL Analytics, you need to send your telemetry data to a log analytics account and not a storage account or an event hub. And I'll just show you what I mean by that and where this is. It's in diagnostic settings, so it's a little bit buried. And it's not the most obvious thing where you set this up. Also, the portal's acting slow, which isn't helping us. So here, I don't have a diagnostic setting configured, so I'll go ahead and do that. So here I can tell it to collect all logs in basic workload management. There's kind of two data streams here. So there's a logging data stream and there's an audit data stream. And here I can send this to a log analytics workspace. This is what you want to do to take advantage of, and it looks like something's screwed up, to take advantage of SQL Insights. So you would want to use log analytics. You also have the option to go to a storage account. If you go to a storage account, this is going to be saved in an extended event format. Unfortunately, if you're trying to process those extended event files in Azure, they have to be processed on the same server you created them on. If you want to process them on a VM running SQL Server in Azure or an on-prem server, you can just download them and process them, but you can't process them with a different SQL database. You can also stream them to an event hub, which is a different type of resource in Azure that's kind of designed for streaming data. In that option, they're sent to they're sent in Avro format, which is like a binary JSON. But we're going to focus on log analytics because that's where we get the real benefit. There is an extra cost to this. So log analytics charges you for the per gigabyte of data you send into the log analytics service. Plus, I think it's like $35 per terabyte a month of storage. Typically, the ingestion costs more than the storage. If you have a bunch of really busy databases, this can be very expensive, but for the most part, it hasn't been an issue with our clients because the insights that it provides are very much worth it. There is a dashboard tool that I'm going to show you with some production data, but you can also write custom queries with Kusto query language, which is a language Microsoft has developed. It's fairly similar to SQL. It's got some enhancements that I like. It's different enough that it's annoying if you've written a ton of SQL throughout your career. And this is the beauty of this. Multiple databases can write to one log analytics workspace, and that means you can aggregate all of the data you have in your Azure tenant, or a subscription anyway. In this, I take that back, it's not just subscription. This can span subscriptions. So you can have, as long as multiple subscriptions are all in the same tenant, which the tenant's kind of your domain effectively, you can write to those. We have one client where they have 28 subscriptions and they're writing all to a single log analytics workspace. And once you do that, you get this SQL Analytics Dashboard. And this is a pretty basic one. I'm going to drill into one in a second, but you get this query duration in seconds. You get the number of errors. You get the total time waiting. You get tuning requests are collected there, so things that are recommended. So let's kind of drill into this. You'll note this says preview. So this is in preview. It's showing me the top metric per database. So here I see physical I/O, or in CPU are my two metrics. but I can drill in, and this is across like 30 databases. So if I drill in, I see which databases are busy, which databases are waiting. I can click through, and ultimately this will get me to a log file if it takes me out of a dashboard. Yeah, and here is KQL. So this is an example of some KQL. So it's selecting from Azure Metrics, which is the table, showing me CPU, and it's summarizing in 30-minute intervals. And here we can see a case statement that's determining low, medium, or high. But that's what this dashboards are all built on. And I'll exit this code generator window, go back to my SQL Analytics pool. And then I can also see wait types. So here I can see which queries were waiting on what. So here, here I have an insert statement, and I can see what the waits are on: buffer IO, preemptive IO, latch waits, log rate governor. So that's that one I was telling you, where if you're doing heavy inserts, you may experience some other challenges. So one other thing I just wanted to show you guys real quick, because I think I forgot to put a slide in on it, is automatic tuning. So this is something that is kind of built into, starts in SQL Server 2017. If you're on SQL Server 2017 Enterprise Edition or 2019, it's available to you, but only the first part of this, so only this force plan option. So force plan uses the query store to, if your query has regressed by, I think, 25% in terms of CPU seconds required, it will force the last known good plan, so the previous plan that worked better, to be available for you. So by default, this comes on in SQL Server or Azure SQL. It's off by default in SQL Server, but it is something you can have. Also, you can have create index on by default, and this is where Microsoft will, as I mentioned, kind of use the DTA, but the better DTA. And likewise, you can do the same thing. You can have it drop indexes for you. So if it determines that an index is not needed and not used over time, it will drop those indexes as it sees fit. And that's kind of the automatic stuff. Managed Instance supports both query performance insights and this automatic tuning, but in a slightly different way. One of the things that I discovered with Managed Instances, in order to get your data going into this dashboard, you have to enable it in the portal, the way I showed you for where I was connecting to a log analytics workspace, but you also have to enable it within the instance. So you have to tell the database that it can connect to that log analytics stuff in order to get there. So read-only replicas, this was something I wanted to bring up and I mentioned earlier. If you're on business critical, you can always connect to your readable secondaries because you're in an availability group kind of construct, but those aren't surfaced in the Azure portal anywhere, which is kind of a problem if you're using it for business critical solutions. And I use business critical in the wrong way there. Business critical is a service tier. What I meant, if you're using it for queries that people care about the performance of, you don't have a whole lot of insight into them. So all that cool stuff that I showed you in the portal doesn't show up if you're using these readable replicas. The only way you can grab data from those is to connect with them, like with a tool like SQL DM from IDERA or any other, pick your tool that you want to use. If you connect to your primary database, but with an application intent of read only, it will get connected to the secondary. You can then hit the DMVs and the catalog views that you could typically hit, and those will show you performance information. But otherwise, if you're trying to connect to the portal or even use the query store, you won't see any of that database data or any of that metadata. However, query store traditionally not been supported on readable secondaries. As part of the announcements from Microsoft Ignite in November, Microsoft announced that they were going to support SQL Server or readable secondary query store on SQL 22. So I would expect it to appear in Azure fairly quickly. I hope. A lot of times features, it just kind of depends on what the implementation schedule is. A lot of times you'll see features that show up in Azure SQL before they show up in a new release of SQL Server. But that's not always 100% the case. But I would expect to see this. One other feature that's kind of nifty that I kind of forgot to mention in all this is query store hints. So you can put hints into the query store now in Azure SQL Database, and this will allow you to, when the query store sees a given query, it will execute that query with a SQL will now execute that query with a hint you wanted to pass in. So that's kind of another cool feature that Microsoft recently added that gives you a little bit more control over what you're doing in Azure. But like I said, no query store in the secondaries right now. This really only applies to you if you're in business critical. But you can use whatever SQL tools you wanted to use and connect them with that read intent connection string. Tuning can always be challenging. Performance tuning and identifying, what queries, especially if you're a newer DBA and you have less experience, it's hard to know what matters and what doesn't. The basics are easy. It's find the heaviest queries that are running with the biggest workload and identify them. Fixing the problems is a little bit harder, but what really helps is knowing your baseline. So knowing what your baseline performance looks like. One of the cool things with alerts in Azure is you can configure smart alerts. So you can alert based on the baseline of the server. So they'll kind of track the history for you. And then once you know your baseline, tune those outliers. So when you see things drift away, remember one thing that I kind of didn't mention, indexes and statistics they get auto updated per normal auto update rules, but they may not, you may need to update stats or rebuild indexes more frequently than they're going to get auto updated. So just be aware of that. And then take advantage of the tools Microsoft offers. There's a lot of really cool stuff built into the Azure platform to give you performance information about your databases. So take advantage of those tools, collect that data and log analytics, and quickly identify what performance problems you're going to have. And with that, I'd like to hand off to Justin, who's going to talk about some cool new stuff IDERA has for Azure.
All right, thanks, Joey. I appreciate it. Hopefully, everyone can hear me. Let me share my screen.
Yeah, you're good. You're good, sound-wise.
I appreciate it. Okay, so first and foremost, when I think about this discussion, when listening to Joey, it's real clear that figuring out the baseline and figuring out what's normal in your SQL environment and having a history to it can be very, very important. To that end, IDERA is primarily known for our performance monitoring tool, SQL Diagnostic Manager. Typically, this tool is used for three main purposes. It's here to monitor your SQL instances 24/7. And it's here to work with not only just your on-prem instances, but also if you have VMs in VMware or Hyper-V, or if you are using AWS, Amazon Web Services, maybe you've got full VMs out in AWS, or maybe you're using the RDS service. And then going a step further, if you go into, for example, Azure, here we can, with this tool, Diagnostic Manager, we can monitor, database as a service. We can also monitor managed instances, and of course, we can look at elastic pools as well as full VMs. Really, full VMs anywhere. I mean, you can use any monitoring tool really for that. But one of the things that we think is important is trying to get the most out of your Azure environment. Another thing we've noted is that people are moving more towards the cloud in general. So a few things that we started by adding are, when you add SQL instances into IDERA's Diagnostic Manager, one of the things that we do is we have custom templates for the different offerings that are in the cloud. So not only do we have a default template, which is really the go-to or the standard template that most people use, but we also have a critical only for QA. We have a high performance template, and then specific templates for RDS, Azure, and managed instances. Now, just to look at what the templates would show, if I'm looking at any given server and I right-click on it and went to configure alerts, this would bring up a dialog box that shows you all the different metrics that we're monitoring. So it's everything from the health of availability groups, when your last backup occurred. Of course, that's not going to be very important if you're in Azure. down here we can see the status of mirrors. We can, of course, look at all the sessions and connections. We can look for your high impact queries. There's just a myriad of different things that we're looking at. The other thing to mention is that, and going back to sort of the baseline concept, we do offer both static metrics as well as dynamic metrics. Dynamic metrics are based off of a baselining. So if you added a database as a service or a managed instance, Diagnostic Manager would start to try to figure out what was normal in your environment. And that sort of goes back to what Joey said about this one server that he was working with that had a 20% load and then switched to an 80% load on CPU. This baselining is automatic, so there's nothing that you have to do in the background. We're going to automatically start to dynamically try to figure out what's normal in your environment. And then we'll also, like I said, give you the opportunity to use dynamic metrics, which means that you can account for different periods of time. So for example, if during the day there's a certain regular workload, but at night when your maintenance window opens up, or maybe you have some offshore partners or after hours teams, you can still baseline and find out what's normal for that period of time. And if you're using dynamic metrics, you won't be alerted or sent out notifications about problems that aren't problems. Okay, so these templates that are added, once you are adding a SQL instance, that's when the template's added. One of the newer features that we have added is the ability to connect up to your subscription, specifically in Azure, right? So obviously we're not going to be able to use Windows authentication for database as a service. So if I come in here and pick SQL Server authentication, and for whatever reason, everything's going real slow right there, I can enable Azure Discover settings. And if I've created a profile, and I'm not going to go into the profile, I would usually go into Manage Profile here, but I don't want to give all that information out on a recording. But basically, you can select a profile, and once you've selected that profile, it will enumerate all the different instances or managed instances or databases of services that are out there. Now, the reason why I think this is important is obviously if you're using database as a service, you're not going to have the browser service. So even though you can manually, if you know all the options to get to your database as a service, you can do that. But if you don't, you can bring up or enable Azure Discovery settings and bring up that connection to your subscription and see all your resources, without having to, know the exact path to the database as a service, as like we were saying. So after you've connected and added SQL instances, there's a few other things that are important to note. We have added a whole bunch of different metrics specifically around sizing. One of the things that's I think is important is the agile capabilities of Azure. If I need to spin up and give myself more resources, I can easily do that. If I need to remove resources, I can easily do that as well. So a lot of times we want to know when a database as a service or a managed instance is having a hard time, for example, or not being utilized. So one of the things that we do is, and I'm just going to go into this configure alerts section again, is we've added in a whole bunch of database as a service specific metrics. So max worker loads if they're high or if they're low. So if you're not taking advantage of your instance, we can alert you to that so that you're not overpaying. And then the option B, if your instance is not powered enough, we can alert you to that as well, so that you can know what's going on with your instance and make sure you're getting the most of it, and of course not overpaying. Another area that we've gone into is we've added custom counters. So for example, if I go to the administration section of Diagnostic Manager, I can now come into custom counters, and I can add counters in all sorts of different areas. So I can add WMI counters, perfmon counters, SQL Server counters. I can even add scripts specifically. If I want to have my own custom script be added as a counter, it can be done. And then the other thing that we can do is add Azure server counters. As Joey said, or showing you, there are a whole bunch of counters that are available to you. You can incorporate all these counters into your monitoring tool as needed. I'm just going to go look at one instance really quickly. I'll select a profile. I'm going to pick Elastic Pools, And then down here, I can look at different resources. So here, I'm going to look at a specific server, and we'll progress on. And I'm going to select a metric for it specifically. Let's look at CPU used, and I can put in a scale. But the takeaway with this is that I can add extra counters if that's something I want. And of course, I can get different specific information back from it now that I'm tied in with the Azure Portal, or Azure Profile rather, not Portal specifically. Okay, so as you can imagine, all the standard bells and whistles do apply when we're talking about monitoring. One of the areas I do want to highlight is that when you're looking at query information. So, for example, I'm going to look at this database as a service. If I went to query information, one of the things I think is important to note is that we are now using Query Store, which, in my opinion, is great because you don't have to necessarily be doing anything. The load for monitoring your high impact queries is already being it's already turned on by default. Unless again you moved an older database out into the cloud. But basically, when I'm looking at this query information, I can pick it all up via Query Store, and I can do that for very little impact. Side note: we also have weight monitoring. So if I'm looking at a SQL instance and I want to again maybe use Query Store, I can go in and look at weight statistics. And I can look at it at the weight level, but I can also look at the statement level. So if I want to know what this workload is coming from, or a specific application that's causing work. And then keep in mind, this is also available historically. So if I needed to go back to, let's say, the 12th, I could easily jump back to that point in time and see what was going on any given SQL instance. Okay, so let's see. What other big areas do I want to highlight? Well, one other thing I will say is that we did go in, and under the property section, we have added specific recommendations for RDS and Azure. So, for example, if you want to get an analysis of your cloud offerings and see that you're taking advantage of everything or every option, you can actually go in and run an analysis inside Diagnostic Manager, and that'll come back with database configuration options and server configuration options, and specifically it'll also give you recommendations for, like I said, RDS and Azure, either or. Okay, so let's see. The other thing that I do want to highlight is that we do tie in with vCenter and Hyper-V. So if you need to have a connection to your underlying host, we can easily add that. How that comes out is if you're looking at a SQL instance that is a VM, then when you look at things like the CPU, you can actually see the underlying host as well as the VM. So if your performance problem is really coming from your underlying host, you can identify that with Virtualization Monitoring built into Diagnostic Manager. And there's a lot here. I mean, like I said, we can always run an analysis and get you recommendations for things you can do differently. If you want to look at the session information and see exactly who's connected and what they're doing in your environment, you can easily do that with Diagnostic Manager. Also, again, this is available historically. So if I want to go back and look at this session information from a different day, I can easily do that with the tool. But with that, I know we're coming close to the top of the hour, and I'm sure we have some questions. So just as a side note, if you need to or would like to trial this product, all our products from IDERA come with 2-week trials. All you have to do is go to our main website, and you can download them and trial them for free in your environment. But let me turn it over to Greg to close this out.
All right, thanks, Justin. All right, I'm gonna just pop up a poll question, and we'll do the Q&A here. So do that. So one question somebody asked was, it looks like Joey showed a lot of different tools in the Azure Portal. So does SQL Diagnostic Manager just kind of pull it all together into one interface?
Well, I would say that yes, we're working on that, but it's a newer development moving to the cloud. So what I would say is, yes, this is a centralized monitoring tool, but it's not just for Azure. You know, if you have on-prem servers or VMs or multiple sites, you know, all of those things come into play. So, you know, I don't know, and might be wrong. Joey can correct me on this. I don't know that many companies that are 100% cloud oriented. Maybe some big banks or something like that. But yes, this would be a centralized collaboration tool.
Yeah, I would definitely say that, like, I have a lot of clients that are 100% cloud. I have very few clients that are 100% like running PaaS databases on the cloud. So a lot of them are still running VMs.
Yeah.
For a lot of their workloads.
Okay. Another question, Justin, is about the history. I think Joey mentioned there's 45 days in Azure Portal. So does this go back further than that?
It can. By default, we hold 90 days worth of history in our tool, but you can set the grooming options any way you'd like. So if you want to hold the whole year's worth of data, that's not a problem. You can have all that information. It's entirely up to you. The only difference, the only thing that I would say is that the more data you hold, obviously, the more space you have to account for in the repository that's tied to Diagnostic Manager.
Okay. Let's see. So another question somebody asked early on, Joey, and I guess this is kind of for both you guys, is just wondering about using and collecting these metrics. Is there actually costs on the Azure platform for collecting and viewing all this data?
So Log Analytics has costs associated with it. There are two dimensions of the cost model there. That's ingestion, so like how much data streams into Log Analytics, and then how much you store. I don't remember the default storage off the top of my head, but I think it's like 30 days. In my experience, that hasn't been a big deal. The metrics data is kind of built in. So the metrics data that you store is built into the cost. If you store additional or add alerts, there are small costs associated with that.
Okay. And then Justin, somebody had a question about just the storage for SQL DM. Where is all that information stored?
So Diagnostic Manager has its own repository, and I don't think you can see this, but so you would store it on a SQL database. A SQL database, usually I would say that you would need to have it on-prem, or you would at least need it to be a VM somewhere, because we do use the SQL Server agent, and there are services associated with Diagnostic Manager. Typically, for sizing, if you're holding a year's worth of data, that would usually equate to 3 gigs per monitored instance per year. So if you're monitoring 10 instances, you can pretty much assume that the database will fill up to be about 30 gigs for 10 instances. Now, we do also have grooming built in, so the older data is automatically scrubbed out of your history based on how much history you want to keep.
Okay. Let's see. I guess we'll just do one last question and maybe just some additional information. So if somebody wanted to download a trial, where can they go and get that, and how does that work?
Yeah, it's just www.idera.com. On the main page at the very top, you'll see SQL Diagnostic Manager. You can click on that, and then right off to the right on that page is trial for or start for free. So you click on that. Once you've downloaded the product, it comes automatically with a 2-week trial. So you're already up and running, and it will trial for 15 instances during that 2 week. And of course, if you need to extend, we can always extend the licensing so that you can do a full POC if that's something you would like to do.
Okay, great. All right, I'm going to wrap things up. So with that, I want to thank Joey and Justin for sharing all that information today, and also thank IDERA for sponsoring today's event. The webinar was recorded, and you'll receive a follow-up email with links, as well as a link to download the slides. Also, please visit mssqltips.com to access all of our free SQL Server resources and check out all of our upcoming SQL Server webinars. Everything's always free on the site, so hopefully we'll see you in the future. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.